Hello friends. I am Satish Lele. This video is part of my chemical process piping channel on YouTube. This video is about pumps, compressors, fans and blowers. Centrifugal pumps. A centrifugal pump is a rotary dynamic pump that uses a rotating impeller to increase the pressure of a fluid. Centrifugal pumps are commonly used to move liquids through a piping system. The fluid enters the pump impeller along or near to the rotating axis and is accelerated by the impeller, flowing radially outward into a diffuser or load chamber casing, from where it exits into the downstream piping system. Centrifugal pumps are used for large discharge through smaller heads. The centrifugal pump is a kinetic machine converting mechanical energy into hydraulic energy through centrifugal activity. Its purpose is to convert energy of an electric motor or engine into velocity or kinetic energy and then into pressure of a fluid that is being pumped. The centrifugal pump is one of the simplest pieces of equipment. The energy changes occur into two main parts of the pump, the impeller and the volute. The impeller is the rotating part that converts driver energy into the kinetic energy. The volute is the stationary part that converts the kinetic energy into pressure. Liquid enters the pump suction and then the eye of the impeller. When the impeller rotates, it spins the liquid sitting in the cavities between the vanes outward and imparts centrifugal acceleration. Multi-stage centrifugal pumps. The centrifugal pump containing two or more impellers is called a multi-stage centrifugal pump. The impellers may be mounted on the same shaft or on different shafts. If we need higher pressure at the outlet, we can connect impellers in series. If we need a higher flow output, we can connect impellers in parallel. All energy added to the fluid comes from the power of the electric or other motor force driving the impeller. Vertical inline pumps. Vertical inline closed-coupled pumps are specifically designed for mounting, in any position, directly in the pipeline. The suction and discharge nozzles are located on the same center line 180 degrees apart. Vertical pumps significantly reduce the space required. Two pumps fit in the space of one. They are easy to maintain. Simply remove the cap screws and the motor and bracket assembly is easily removed from the casing without disturbing the piping. The impeller is direct coupled to the motor shaft for easy maintenance to minimize impeller wear out and reduce noise. Most pump parts, except for the casing, are 100% interchangeable. The inline casing has provisions for mounting an optional support base should the pump sit on the floor. Mechanical seals can be provided as standard to prevent leakage around the shaft. The release line may be provided from the seal bases to the pump discharge for flushing and venting purposes. Suction branch design pre-rotates suction liquid in the direction of pump impeller rotation. This concept minimizes pumping noise that is otherwise associated with more common short radius suction inlet designs. Cavitation. Within a centrifugal pump, the flow area of the eye of the pump impeller is usually smaller than either the flow area of the pump suction piping or the flow area through the impeller vanes. When the liquid being pumped enters the eye of a centrifugal pump, the decrease in flow area results in an increase in flow velocity accompanied by a decrease in pressure. The greater the pump flow rate, the greater the pressure drop between the pump suction and the eye of the impeller. If the pressure drop is large enough, or if the temperature is high enough, the pressure drop may be sufficient to cause the liquid to flash to vapor when the local pressure falls below the saturation pressure for the fluid being pumped. Any vapor bubbles formed by the pressure drop at the eye of the impeller are swept along the impeller vanes by the flow of the fluid. For high pump flow rate, greater pressure drop is between pump suction and eye of impeller. Liquid will vaporize when local pressure falls below saturation saturation pressure for fluid being pumped, if pressure drop is large enough or if temperature is high enough. When the bubbles enter a region where local pressure is greater than saturation pressure farther out the impeller vane, the vapor bubbles abruptly collapse. This process of the formation and subsequent collapse of vapor bubbles in a pump is called cavitation. Cavitation in a centrifugal pump has a significant effect on pump performance. Cavitation degrades the performance of a pump, resulting in a fluctuating flow rate and discharge pressure. Cavitation can also be destructive to pumps' internal components. When a pump cavitates, vapor bubbles form in the low-pressure region directly behind the rotating impeller vanes. These vapor bubbles then move towards the oncoming impeller vane, where they collapse and cause a physical shock to the leading edge of the impeller vane. This physical shock creates small pits on the leading edge of the impeller vane. Each individual pit is microscopic in size, but the cumulative effect of millions of these pits formed over a period of hours or days can literally destroy a pump impeller. Cavitation can also cause excessive pump vibration, which could damage pump bearings, wearing rings, and seals. A small number of centrifugal pumps are designed to operate under conditions where cavitation is unavoidable. These pumps must be specially designed and maintained to withstand the small amount of cavitation that occurs during their operation. Most centrifugal pumps are not designed to withstand sustained cavitation. Noise is one of the indications that a centrifugal pump is cavitating. A cavitating pump can sound like a can of marbles being shaken. Other indications that can be observed from a remote operating station are fluctuating discharge pressure, flow rate, and pump motor current. Pump curves. It gives the best efficiency point, which is the point at which effects of head or pressure and flow converge to produce the greatest amount of output for the least amount of energy. For a specified impeller diameter and speed, the centrifugal pump has a fixed and predictable performance curve. The point where the pump operates on its curve is dependent upon the characteristics of the system in which it is operating, commonly called the system head curve, or the relationship between flow and hydraulic losses in the system. This representation is in the graphic form, and since friction losses vary in the square of the flow rate, the system curve is parabolic in shape. Step 1. The basic pump curves are no different than reading any other head flow curve. For a known head value, follow the head over to the pump curve, then drop down to the capacity axis, and this will be the flow rate. What you are trying to figure out here is what diameter impeller is needed to get the required head and capacity. Step 2. The next thing to figure out is what motor is needed to drive this impeller without overloading. To do this, use the dashed horsepower lines. To the right of the horsepower line is overloading and to the left is non-overloading. Selecting an impeller diameter where the line does not cross the dashed HP curve is a non-overloading pump. Step 3. The last thing to determine is at what pump efficiency the pump will operate. Look at the U-shaped lines and interpolate to get the efficiency. Pump location and layout. If available floor area is limited, the vertical unit generally requires less area. However, if available headroom is limited, the horizontal unit almost invariably requires less headroom. It should be kept in mind that area and height requirements will differ somewhat between various manufacturers and with the type of configuration of the unit specified. NPSH, net positive suction head. The margin of pressure over vapor pressure at the pump suction nozzle is net positive suction head NPSH. NPSH is the difference between suction pressure stagnation and vapor pressure. In equation form, NPSH equals PS, PVOP. with MPSH equals MPSH available from the system at the pump inlet with the pump running. PS equals stagnation suction pressure at the pump inlet with the pump running. PVF equals vapor pressure of the pumpage at inlet temperature. Suction pressure is the first half of MPSH equation. Suction pressure must be determined at pump suction nozzle when pump is running. If suction pressure is measured with gauge, atmospheric pressure at pump location must be added to gauge reading to convert reading to absolute pressure. Vapor pressure is the second half of MPSH equation. Vapor pressure is more difficult to determine than suction pressure. Measure of desire of liquid to boil to gas. Some liquids, such as butane and ammonia, have high vapor pressures. They are kept under pressure, or they will boil or flash. Vapor pressure is function of temperature only. As temperature of liquid increases, its vapor pressure increases until critical temperature is reached. At critical temperature, vapor pressure vanishes. Above critical temperature, there is no distinction between liquid and gas, it is all fluid. Units of MPSH. For centrifugal pumps, MPSH values are expressed in units of specific energy equivalent column height such as feet or meters. For displacement pumps, rotary and reciprocating MPSH values are normally expressed in pressure units such as pounds per square inch, 5 kilopascals, or bars. MPSH values are neither gauge pressures nor absolute pressures. The G in front means that the pressure is measured above atmospheric pressure. The A in C means that the pressure is measured above absolute zero, a perfect vacuum. MPSH is a measurement of pressure above vapor pressure, so the units of MPSH in the US are just psi or feet. Compressor. The gas compressor is a mechanical device that increases the pressure of a gas by reducing its volume. Compressors are similar to pumps. Both increase the pressure on a fluid and both can transport the fluid through a pipe. As gases are compressible, the compressor also reduces the volume of a gas. Liquids are relatively incompressible, so the main action of a pump is to transport liquids. There are 4 types of compressors: reciprocating, centrifugal, piston, turbine. There are 2 primary classifications of industrial compressors: intermittent flow positive displacement including reciprocating and rotary types, and continuous flow, including centrifugal and axial flow types. Reciprocating compressors are typically used where high compression ratio of discharge to suction pressures are required per stage without high flow rates, and the process fluid is relatively dry. Wet gas compressors tend to be centrifugal types. High flow, or compression ratio applications are best served by axial flow compressors. Rotary types are primarily specified in compressed air applications, though other types of compressors are also found in air service. Reciprocating compressor. Reciprocating compressors are often some of the most critical and expensive systems at a production facility, and deserve special attention. Various compressors are found in almost every industrial facility. Types of gases compressed include the following: air for compressed tool and instrument air systems, hydrogen, oxygen, etc. for chemical processing, light hydrocarbon fractions in refining, various gases for storage or transmission. Other applications. The centrifugal compressor essentially consists of 3 components: The stationary casing. The rotating impeller is shown in figure, which imparts a high velocity to the air. The impeller may be single or double-sided, but the fundamental theory is same for both. The diffuser consisting of a number of fixed diverging passages in which the air is decelerated with a consequent rise in static pressure. Centrifugal compressor. The centrifugal compressor is a radial flow rotodynamic fluid machine that uses mostly air as the working fluid and utilizes the mechanical energy imparted to the machine from outside to increase the total internal energy of the fluid, mainly in the form of increased static pressure head. Single-width, single-inlet WSI fans are most commonly used when suction duct is required from a fan inlet. The single-width fan has the advantage of providing a connection from the duct straight to the fan inlet, without the use of inlet boxes. Double-width, double-inlet DWDI fans are used primarily in air handling units or in cleaning chambers where the connection of the inlet duct directly to the fan is not a requirement. Inline centrifugal fans combine the performance characteristics of the traditional scroll-type centrifugal fans with the space-saving advantages of axial-type fans. These fans are applicable for general building ventilation, commercial and industrial installations. Air handling unit toggle fans, designed to appeal to fan buyers looking for a less expensive double-width, double-inlet centrifugal fan option. Plus fans are high-performance centrifugal impellers that have been designed for clean or slightly dusty air to achieve the best possible aerodynamic performance when not fitted within conventional fan housing. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.